Morning, students. I wanted to make this quick video to work some more examples of operating with functions. Um, I am at an appointment, so if you are hearing background noise, please excuse it, and I hope that you're able to hear me okay. So we have these two functions, f of x and g of x, and let's do a few examples. We'll start by finding f plus g of x. This simply means that we want to add the two functions together. So it'll be f of x plus g of x. F of x is x plus 2. G of x is 2x squared minus 3x minus 2, and we'll combine like terms. There's nothing to combine with the 2x squared term, so we'll simply bring it down, rewrite it. But we do have a positive x minus 3x that we want to combine. So the invisible coefficient of this x term is a 1. 1 minus 3 is negative 2. So we have negative 2x once we combine those like terms. And lastly, we have a positive 2 and a negative 2 that will cancel out. So our final answer for adding f and g would be 2x squared minus 2x. If we want to talk about the domain of the answer, the domain of 2x squared minus 2x is all real numbers because it's not a special case. It is a quadratic. It looks like a U if you were to graph it. Or go to the table. There would be no holes or gaps in the graph, and there would be no error messages in the table. We talked about that during our last class. So let's make this part A. Let's do part B. This time, let's do g of x divided by f of x. Or as your textbook would write it, they would write g divided by f and put the x like this. They mean the same thing. So this means that we want to put function g in the numerator. So we have 2x squared minus 3x minus 2 in our numerator. And then in the denominator, we have an x plus 2. At this point, there's nothing that we will discuss in terms of simplifying this. But in chapter 3, we will talk about how to factor the numerator if possible. And then we'll be able to cancel out factors, but not yet. So we will leave our answer exactly like it is. And now if we're talking about the domain of g divided by f of x, we need to consider if we have a special case. And in fact, we do. This is a special case. This is what we call a rational function. We have a variable in our denominator that is problematic because we can't divide by 0. So in this special case, to find the domain, we want to exclude where the denominator equals 0. So we do not want x plus 2 to be 0. So we'll do x plus 2, set it equal to 0, and then exclude this point. Or you could just put the not equal sign. We subtract 2 from both sides. When we're solving, we find out that x can be every number except a negative 2. So if we were to look at this on the number line in terms of graphing the domain, and again, I'm sitting outside to avoid the crowd here. Our x value that's permissible in this function, extends from negative infinity, goes all the way to negative 2 and skips over negative 2 and keeps going to positive infinity. So our domain in interval notation will be written as negative infinity to negative 2 using a set of parentheses, skip over, so use your union, and then negative 2 to positive infinity. Let's take a look at this really quickly in the calculator and see what this looks like. So in the calculator, we will have, go to your y equals, clear out what's over there. I'm going to use the fraction function on my calculator by pressing alpha y equals number 1. And then we had, I believe it was 2x squared you all know I don't remember what it was. Let me try to see. I'm working on one screen now, so it's a little 2x squared minus 3x minus 2. Okay, so 2x squared minus 3x minus 2 in the numerator. Go to the denominator, and we will type in the denominator, which is x plus 2. So x plus 2. And now we'll press the graph. We're going to look at the graph. I need to change my settings of the graph because the viewing window isn't what we want it to be. So I'm going to do zoom number 6 to go back to the factory default settings on the zoom window. And we see this is a picture of the graph. All right, so the graph is doing some stuff. If you notice here, our graph gets really, 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 really close to -2, but it never equals it. Now let's look at the table. So second graph for table. When we plug in a -2, we get the error message. And so -2 is restricted. -2 is not allowed in our domain. Also, if we scroll up, we can see we don't get an error message anywhere else. So we get out negative numbers, we get out positive numbers for our output for y, but we have an error message with -2, so -2 is restricted, not included in our domain. All right, let's do one more thing with this one, and then I'm going to make a part 2 for the video, okay? So back here we had, that was part B. Let's make this part C. And let's do a function composition. So again, our functions were f of x equal x minus 2, g of x equal, I don't remember. And it was x plus 2. Oh, my bad. 2x squared minus 3x minus 2. 2x squared minus 3x minus 2. And this g f of x was a plus. All right, so let's find f of g of x. And this is saying we want to take g and plug it into f. So we are taking everything that g is. G is this whole shebang. And we are substituting it in to f in place of this x. So plug g into f. So we'll end up with 2x squared minus 3x minus 2, and we still have that plus 2 that we need to write. And so that equals 2x squared minus 3x minus 2 plus 2, and these cancel. So our final answer is 2x squared minus 3x. That is f of g of x. Now we're going to reverse it, like Missy Elliott said. So part D, f of x was x plus 2. G of x is 2x squared minus 3x minus 2. Make sure I have it right. Okay. And now we want to find g of f of x, which means we are taking f and putting it into g. So we're going to plug f into g. So for every x that we see in function g, we are going to insert f. So we're going to take this whole value of f, which is x plus 2, and we're going to insert it here in place of this x, and here in place of this x. And so the result is we keep the 2, we then have x plus 2 squared, keep the minus 3, replace the x with x plus 2, and keep the minus 2. And now we'll just do the algebra to simplify. So if you don't remember how to FOIL or how to distribute or how to multiply a binomial by itself, please go back to the J section of the textbook and review. I'm going to do it really quickly here. Also, I have other videos posted that you can use to review or refresh your memory. All right, so we have x plus 2 that we want to square, so that's the same thing as x plus 2 times itself. X times x is x squared. X times 2 is a 2x. Distribute the 2 times the x, you get another 2x, and 2 times 2, you get 4. So we have 2 times x squared plus 4x plus 4 minus 3 times x plus 2, bring down to minus 2. Now we can just continue with the algebraic process of simplifying, distribute these. 2 times x squared is 2x squared. 2 times 4x is 8x. 2 times 4 is 8. Distribute the negative 3. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. Bring down your minus 2. And now all you have to do is combine your like terms. There's nothing to combine with the 2x squared, so we will just rewrite it. We have an 8x. We have a minus 3x. 8 minus 3 is 5. So then we have 5x's. And now we have 8 minus 6 minus 2. So 8 minus 6 is 2, and then 2 minus 2 is 0, cancels out. So this is the final answer. What is the domain of our answer? What's the domain of 2x squared plus 5x? You can look at the graph, you can look at the table, you will see that this is simply a polynomial function, it's a quadratic. There are no restrictions. We are allowed to square any number that we want. So our domain is all real numbers. In interval notation, it's written as negative infinity to positive infinity. All right, I will make a part 2 of this in just a few minutes, so stay tuned.